So as I said to you, someone has done a dirty job for you, so you just look at it, this is what you will have. If you have a very long road, which means this one is only the cross section of this long road. Okay, let's say you have an oil pipe suspended in the water, right? You have an oil pipe suspended in the water, okay, in the seabed, or it is suspended like that, because this pipe can be 1 kilo or 5 kilometers and they are having the same diameter, so you can take only this one. So you don't have to care about the length of it. Just take this one is the circular road. For laminar, the drag is 1.2. For turbulent, it is 0.3. So as simple as that, right? But this one is only for long road. I put that in red and blue, right? And the frontal area, okay, this is very important. Sometimes when you have a cylinder, your frontal area, you tend to calculate the perimeter area. While in fact, even though you have a cylinder, or you have a triangular, or you have a pentagon, or you have hexagon, doesn't matter what, when you look from the front, it will look like a rectangular. Right? Doesn't matter what. When you look from here, just square. So that's why you got that. Okay, so for this, let's say for this one, the area will be the diameters times the length. Okay, since the length is unknown, you can make it per meter. So area per meter width. Okay, something like that. You can do that. Okay, the FD is the same. CD half rho V squared times 8. Everything will be the same. Okay, now looking forward, we look at what happens if we have a finite, not infinitely long pipe, but we have a finite geometry like the cube, spin circular disc, horn, sphere, and ellipsoid. Okay, each of it has a different CD. So you can see this one for turbulent, this one for laminars is totally different. Okay, and for the sphere, the laminar occurs when the Reynolds number is less than 200,000. It's different with your flat plate. Your flat plate, the critical Reynolds number is 500,000, but for spheres, it is 200,000. So it is different, right? Ellipsoid also 200,000. Okay. So basically, it's very simple. You just go to the table, get the correlation or the value of C that you have, and then you can calculate your FD. Right? Now, if you look at this, all of these things, you can see that the streamlined body is among the body that has the lowest drag coefficient. 0.04. That's why the shape is widely used in designing your car, your motorcycle, your aircraft, and so on. Even if you look at it, the shape of our submarine, have you ever seen it? Submarine? Okay, if you look at the submarine, it looks like that, right? Like ikan kembung. Then you put the blade there, right? And then you put the dorsal fin there, exactly like your ship. Exactly like the fish. And then, that's it. So you got the submarine. This body. Okay. So actually, nature has teach us how to have the best streamlined body. That's why if you look at the fish, they are having this. Okay, but we still cannot mimic the movement of the fish. Right? Nowadays, we are still having this propeller to drive the submarine. Maybe later on, what happen is this submarine can do that. Then you cannot differentiate whether those one is submarine or a big wheel. And then that is the the ultimate technology of the submarine. Okay. Now, if you remember in your tutorial question number 1, you have a rectangular plate signboard, and the airflow is coming from the side. Now, what happens if the air coming from the front? This is it. Okay, so your drag force is calculated using this one. But remember, this one is only applicable for this. If you have odd ratio of length and d, which is beyond this, then you need to find your own correlation. It is available there in journal, so you can find it. Then for tree and parachute, we also have this kind of thing. Okay, for this parachute, of course, you want the CD to be not so big, but not too small also. Okay, because for the parachute, if it is too big, okay, you will fly there forever. Okay, if it is too small, okay, you need to prepare your feet to handle the impact. So it has to be balanced, right? You do not want it to be big or okay. Now, while I'm standing here, working here and there, actually I spend a lot of energy because of this. Right? Because when I move, actually air is coming to me and I have to overcome that. So, okay, for a standing person like me, the CD times A is average. Of course, it is average for the Westerner, because they are the one who calculate it. For us, maybe it's smaller, because for you, maybe some of you are taller than me. But for me, maybe it's smaller than that. Right? So that's all about it. For a bike, okay, you do that, normal person. When you do rempit, this is what you do, right? Basically, except that on top of you are mimicking your idol, either Marquez or Rossi or Dovizioso, it's also reducing your CD. It reduces both your CD and your frontal area because you cover yourself, right? So it will reduce the drag force, the area and the coefficient of drag, which means ultimately you will reduce your drag force tremendously. That's why when you see the racing bike, the steering rod is really down there under the yoke. But for normal bike, you just do that, okay? Because if you do that, especially for me, you get the back pain. Right? The older you are, the worse it will be. Okay? Okay, and if you are the fan of MotoGP or any motorcycle kind of racing, you see sometimes before overtaking the leader, they following the leader, right? They follow it. They call it towing. Like towing, or sometimes Marquez get heated argument with Iannone because he follows him during the qualification. Because actually, those rider behind it has a very big advantages as compared to the front one. Okay. You see, if you drive alone or you ride alone, your CD is 0.9. But if you hide below or behind those leader, you see, the CD is 0.5. So if you are a smart rider, you just follow them closely, right? So you will manage your tire better, you will manage your fuel better, because you have lower drag coefficient. Okay, in the last lap, you just overtake, then ciao. Okay, so even if you do racing, fluid mechanics is still there, right? It is not that I do not want to become an engineer, I want to be a racer. Unfortunately, fluid mechanics is still following you, right? I told you, right? Even if you die, you're buried there, your fluid will move out from your body, which means if you have movement of fluid mechanics is still there. this big trailer, some of those trailers are installed with the fairing. You see those fairing on top of the trailer? It is not there for the purpose of because the driver loves to have those. No. It is there to reduce the drag. Otherwise, you will have a very high drag for this truck. Okay, with fairing it is 0.76. If you have Ferrari, or you can sell it now by Tesla. Tesla has a better CD, right? So for a passenger car or sports car, the CD is 0.3. Okay. If I remember correctly, Beza is 0.28. So Beza is among the lowest the lowest drag. I mean, among the car that has the lowest drag coefficient in Malaysia. If you have a minivan like me, okay, you have a big family, right? You have a big family, you need to bring your parent, your grandparent, your auntie, your uncle, and all your niece, nephew with you. And you have this, the CD will be 0.4. Still better than a bus. Because bus and truck is mostly about 0.96, but minivan is 0.4. Okay? For a high-rise building, it depends. It can be 1 or 1.4, depending on the shape of your building.